Welcome to this last talk, or second last talk of the day. I see you're all seated up there so you can get out fast. That's good. I was supposed to be here with Rustam, and Rustam was unfortunately not able to be here, so you'll have to cope with me. And if that makes you cry or very sad, I have some towels here, so you can wipe your tears. So just if you cry and want to leave, you can go by here and get a towel first. So, some words about me. I'm the Jakarta EE developer advocate at Eclipse Foundation. I'm a Java champion and organises pro. I contribute to a lot of open source organizations and projects. And these are my social media coordinates if you want to follow me or ask questions or anything. If you have any questions during this talk, you can use Slido. So if you have the Slido or your phone up, you can scan this QR code. I'll also repeat this at the end. But here you can ask questions during the talk, and I'll try to answer them at the end. So this talk is about Jakarta EE and CRaC. And just to be sure we're on the same page, I'll do some slides about Jakarta EE first, and then I'll do some of Slack, and then I'll show some demo code of how to do it afterwards. So, if we look at, you probably haven't missed that Java is 30 years this year. So back in 1995, Java was created, and Java was created for set-top boxes and TVs, and great UI and dancing dukes on tablets. But it soon turned out to be very good for server-side development as well. So J2EE came along in 1999. It was a predecessor before that called I think it was JCE or JE or something. But J2EE came around and conquered the world, and has been a tremendous success since that. And it's what mostly powers all financial transactions out there. And it's probably one of the biggest reasons why we're even here today as Java developers. Since J2EE has been the dominant thing, or Java has been the dominant thing on the server side. But of course, J2EE wasn't just simple, and it was at some points a little bit over-engineered. So Spring came around in 2004 trying to address some of these issues with J2EE, the complexity of it. And it did. And Spring became very popular. And at that time, Spring was probably a little bit better than J2EE. It kind of replaced the XML configuration and the interface stuff in J2EE with some XML configuration and interfaces and stuff in Spring. So we went from one XML format to another, but people seem to like that better. Then they also introduced the concept of dependency injection in Java. And Java EE, which J2EE was rebranded to in 2006, came along and kind of tried to catch up with the stuff Spring had done, and did that. And at that time, Spring and Java EE was kind of similar. And also at that time around there, JSR 330 came around, which gave us annotation-based dependency injection in Java. So you can use add inject or add autowired in Spring interchangeably. And so now we were having two very modern, nice, similar platforms that had annotation-based dependency injection, and we got rid of more and more XML configuration and could go to the Java-based one. And at that point, Java EE and Spring were fairly comparable in complexity and what they solved. And then Spring Boot came along in 2004 and kind of changed the picture again. And Spring Boot is now the dominant framework for server-side development. And it has continued to be that. And in 2017, we moved Java EE over to Eclipse Foundation and rebranded it yet again, but this time Jakarta EE. And after a period of getting all the IP and everything set up so we can start working on it, we released Jakarta EE 9 in 2020, where we introduced the namespace change from JavaX to Jakarta, which is kind of a part of this transition from JCP to Eclipse Foundation. And you probably have experienced some implications of that namespace change since that. Right now, we're in the process of delivering Jakarta EE 11. And I say 2024-5 there because parts of it was delivered in December. We got core profile released in December. Web profile was released a couple of weeks ago, or a month ago. And the platform will be released next month. And if you look at the timeline for Jakarta EE alone and not with the other things, you see that in 2020 we did Jakarta EE 9, which was a big thing. It didn't introduce any other changes than the namespace change, and that was deliberate because we wanted to make that transition as easy as possible. And if we had done API changes there as well, this migration from Spring Boot 2 to Spring Boot 3, for example, would have been a hell of a lot more difficult. So Jakarta EE 9 was limited to that namespace change. And then in 2022, we released Jakarta EE 10. And there we introduced a new Jakarta EE core profile, which is a smaller core profile than the web profile, and I'll get back to the details about that one in a couple of slides. And now we're releasing Jakarta EE 11. We're actually in the process also of planning for Jakarta EE 12. So we're moving along with approximately a 2-year release cadence. And so this is kind of a little timeline things. And I'll get to the CRaC thing soon. But just to be differentiating how Spring, for example, differs from Jakarta EE is, while Spring is a framework, Jakarta EE is a set of specifications. And a specification is a specification document or a human-readable text that describes a technology. It has an API artifact that we as developers can use, and it has a TCK or test compatibility kit that tests and verifies that an implementation fulfills all the requirements of a specification. And when it does that, it's a compatible implementation. And we need at least one open source compatible implementation to call a spec final, so to verify that it's implementable. And Jakarta EE 10 is the current release out there. This is the last time I've shown this slide because next month we have 11 out completely. And if we look at 10, this is compared to 9. All the blue ones were updated from between 9 and 10. And there was one new one, CDI Lite, down in the corner. I'll get back to what that was. If we compare this one to what we're doing now in 11, you can see it's about the same amount of blue. So a little less, but it is still a significant upgrade of the platform. We're also adding the Jakarta data specification there. So if we look at Jakarta EE 11 in a little bit more detail, this is the Jakarta EE 11 platform. And that is the complete set of specification that is under the name Jakarta EE 11. And you can see that most of them are about half of them are updated in this release. If we take a subset of the platform, it's the Jakarta EE web profile. And web profile is more targeting the traditional web application and doesn't have the enterprisey stuff. But it has everything you need to create a web UI, to RESTful web services, the JSON processing and binding and security, etc., etc. And we also added Jakarta data, which is a replica or a inspiration from Spring data. So if you know Spring data, you also know Jakarta data. And you may say we copy it, but it's more about taken inspiration from it and acknowledging that this is a good piece of technology developed in the Spring framework, and we want to standardize it in Jakarta EE. So if we look at the core profile then, which is a subset of the web profile again, these profiles may not necessarily be subset of each other in the future, but right now they are. And the core profile is a lighter, smaller profile that is targeting microservices or headless services or whatever you want, RESTful endpoints. And this is the kind of specification that you would need to create that kind of services. And one of the key specifications here is CDI Lite, which is a subset of CDI, and it resolves the dynamic features of CDI at compile time rather than at runtime. So all the dynamic things that CDI resolves at runtime, it can now do at compile time. So we're able to compile to native using GraalVM, if it's a core profile implementation. And Jakarta 11 runs on Java SE 17 and 21. The API sources are compiled with 17 because we want to enable people that are still on 17 to also be able to use Jakarta 11. But the majority of implementations would probably jump to 21 directly. And we as app developers can always use Java 21, even though the APIs are compiled to 17. And that's because we make sure it runs on 17 and 21. And all the demos I'm showing today actually runs on Java 24, so it is not limited to 21 even if you want to go further. And with this release, we kind of established that release cadence of 2 years. We say that we want to release a version of Jakarta EE about 6 to 9 months after the latest LTS of Java. And Java 21 was released, that's a little bit longer ago now, since we're a little bit delayed with this release. But it was supposed to come out summer last year. So we're 1 year delayed, but the plan was to release it, and then we would have made the 2 year cadence. And if you look at the specifications alone, they were feature complete and all released as milestone 4 in May 2024. So it's a year ago. And the reason why we're now, in a year later, releasing the platform is because we're refactoring the TCK, or the test compatibility kit, the test that verifies that an implementation is compatible. And the reason why we're spending so much time on that is it's a bigger job than we anticipated. We're moving it from a test framework that was created back in 1999 or around 2000 called Java Test Harnessed, and it's been moved over to modern technologies using Maven, JUnit, and Archillion. So we can attract younger developers to help with the TCKs as well, because these old test frameworks, nobody wants to work with them. So we're doing this investment now with the cost of being a little late with this release, but we're planning for 12 to release it as planned next summer. So then we will be back on the 2 year cadence. And as you see, we released core profile in December. Web profile came out in beginning of April, and we're releasing the platform next month. So let's look at CRaC. And CRaC is coordinated restore at checkpoint. And the thought about CRaC is that if you have a running application that is aware that it has been started, you can create a checkpoint, kind of the same way as you do when you close the lid of your laptop and go home for the day. When you open it the next morning, it's back where you were. You don't have to reboot it or restart it or anything. It starts exactly the same state as it were when you went home. And with CRaC, you should be able to be aware of when the restore happening, so you can continue running that application. So that's all the concept of CRaC. It's actually very simple. It's the same thing as closing the lid on a laptop and opening it up again. And you should be able to just continue running. And why are we doing that? If we want to be able to reduce the startup time of an application. So a regular Java application on the top here, you would have to first have the JVM start up and then the application start up, and it will take some time before you have full performance of it, and it gets optimized, and then it's get faster and faster. And after a while, it reaches sort of a level of performance. And that is the same no matter if you start it the first, second, or third time, because it still has to do the same thing. So what if we could take a snapshot when it had started and then just start it from there, like you see on the lower picture here. The first run will be the same as any run. Then we do a checkpoint, and the next time we start it, we can start from there and have full performance from the first moment. So that is the thinking behind CRaC. But there are some things to think about there, because when your application is running in the JVM, and JVM also has some warm things and stuff, and the application may or may not contain references to all kinds of resources and stuff. It can have file handles, or it can have database connections, or any other things that we may do in your application. It's rarely an application that is just self-contained. It's usually using something outside of the application. And these resources has to sort of be handled. So we need to have some way to be aware of when a checkpoint is happening. So right before that checkpoint is happening, we do some things to take care of those resources. And at the same time, when the application starts up again, right after it's restored, we need to kind of clean up that stuff and make it sure it's exactly the same state it was when we did the checkdown, the checkpoint. And that is the before checkpoint and after restore kind of things we have to think of. And we have to do that for every resource within the application. So to start a CRaC-based application and be able to set that checkpoint, since it's not a default thing in the JVM, it's in OpenJDK. It's an OpenJDK project, and since it's not part of OpenJDK yet, you have to kind of tell the JVM that there is some CRaC things that's going to happen, and if it's a JVM that supports it, it will acknowledge these flags. And there are a couple of implementations that do support that, and one of them is Zulu from Azul. So if you want to use CRaC, you need to use that distribution or any other that has CRaC enabled. And at the same time, to be able to restore it from that checkpoint, and that checkpoint is a file that is just stored on disk somewhere. So when you restore it, you just have to point it to that file so you can read up and start from where it was. So it's these two kind of handles you have to give the JVM. And there are some other choices to make as well. There's something called CRaC engines. And the default CRaC engine is something, if you're into Linux, you probably have heard of CREU, or checkpoint restore in user space. So that's a Linux thing, and that makes that means that those CRaC implementations that are relying on CREU or using that underneath can only run on Linux. And that may not be a problem, because most of us are running Linux in the containers anyway. So CREU can be good, but it's not necessarily always very good, because you have some you may have some issues with the process IDs and things that maybe have to be handled with CREU. So luckily, there is another option called Warp. And Warp is something that is created by Azul. So it's not a standard thing, but you can tell your Zulu JVM that it should use Warp rather than CRaC, and that works fine on Mac as well. I'm not sure if it works on Windows, but you have to read the documentation there. But probably, but at least it works on Mac as well as Linux, and it doesn't use CRaC, and it takes away some of those problems that CRaC has. So CRaC is actually a very simple concept. It's kind of the laptop lid. So let's look at Jakarta EE and CRaC and how Jakarta EE can help us with this. And luckily in Jakarta EE we have a lot of managed resources. So a lot of stuff is managed by the application server, and there are events sent here and there in the system. So we will be the application server will be aware of these when it starts and stops. So there may be things that are very much easier to do in an application on an application server than if you're running just on the JVM itself. So this picture with the application that has resources all runs within an application server, and you may have external resources like connections to databases or other systems that may have to be handled and restored, and a big deal of them can probably be handled by the application server itself. You just may have to hook into it. Another part of it you may have to do manually, and that's how I'm going to show in this demo. But there are some help coming in Jakarta EE, and that's especially coming from CDI, or Jakarta Context and Dependency Injection. And one of them are CDI application lifecycle events. And the lifecycle events of CDI are these. You have an event before you start discovering beans. You have something after you discover what types they are. And then after you have discovered the beans, you can do something. After you have validated the deployment. And you also have a lifecycle event before you shut down the application server. So these are events that you can catch in the system and use for particular kinds of resources. It depends on which resources you have or use in your application, which one actually applies best to what you're doing. There are also some bean discovery events that can be useful. And there are quite a few of them. You have when you process annotated type injection points, you process the injection target, you process bean attributes and process beans, producers and producer observers. So all of these are bean lifecycle events that you can also use to observe and do things based on when these events happen. And finally, we also have CDI scopes. And CDI scopes are for example, application scoped, which is a scope of, if a bean has an application scoped, it starts when it's initialized when the application is started. So it's sort of a singleton. So it's one bean that starts when your application is started. You also have a session scopes that handles the user sessions. So if you have user sessions that you want to take care of when you shut down the checkpoint, that is something you can use there. Request scoped is per request. That's probably not that relevant for to help you with CRaC, but that is a bean is created per request. And you can also have custom scopes that different, you can create them yourself, or different parts of the specification have created custom scopes. That could be, for example, over a dialogue in a view, for example. So, and what helps with these to have a clue of what's happening with these scoped beans is that you can use the add observes that will let you catch an event when something happens. And in this example, I'm observing when an application scope class is initialized. So when that class is created, then I know, or that scope is created, initialized, then I can do things. At the same time, I can also observe when it is destroyed, and I can do things. So there are some help in the Jakarta specifications that can help you do the things you need to take care of your resources when you create a checkpoint. And this is an example where I observed the application scopes class, and in this method I would do the whatever I have to do to catch some state, for example. I'll show an example in a minute. And the same way here, I'm observing the destroyed. So this is how we can use these annotation add observed, add observes, add initialized, etc., and put it into the scope that you're observing. There's also a CRaC API that is helpful or necessary, actually. And the CRaC API is an interface called resource, and it has two methods. It has before checkpoint and after restore. And it's kind of self-explanatory what they are doing. That's in the before checkpoint method, that's where you have to do the things to take care of the resources before you create the checkpoint. And after restore, that's where you enable those resources again. And this is a API that is under CRaC. It's open source out there. It's under the OpenJDK, but it's a project on its own, and it's version 1.50 right now. So, and the way you use these in Jakarta EE, it's that you have a listener that you can have application scoped on. So this one will happen. So you will have it alive during the application lifecycle. And you can see it implements resource, and it has this before checkpoint and after restore method, where I can do the implementations, and I'll show that in the demo. So let's look at the code. So here I have an application. I'm using two runtimes that I can use for this one. I have Helidon and I have Quarkus. And the good thing about these are all Jakarta EE applications. So I can just use the same code for both of them. And the application is very simple. It's an Jakarta RESTful application. It has a random controller that will just produce JSON, and that JSON would be a pair of random strings, and these random strings are just read up from a enum that I have here with the nouns and the adjectives. So we just combine two random words together. So it's a very simple application. It just does this stuff. But I have some CRaC things here, and if you look at this. This class, this is where I kind of initialize the adjectives from a text file here, and the nouns. So this is kind of where I set it up, and where I can generate the random string pair. So this is the business logic of the application where I read stuff. The interesting thing is that this one also implements the resource. Like, remember the CRaC API. And down at the bottom here, I'm implementing these two methods, before checkpoint and after restore. And at this point, since I'm reading in the files and caching them, I don't really need to do anything in these restore methods. So I'm just printing that if I had a file handle open, I could close it, and I can recreate it if I need to create it. So this is where you would do these kind of things. To help show that this one is actually faster with CRaC than without CRaC, I also have a startup listener that is also application scopes, and here I observed when application scoped is initialized. So here I can do things. So I print a little bit here that it's initialized. I print out a timestamp that I send into the application. I set a timestamp in the container that I send into the application. And then I check how much time has gone when this method is called. And then I print out how much time did it take to do this. And in between here, I calculate the Fibonacci numbers up to 42, just to make sure it takes a little while to do this. I could calculate longer number to make it even more obvious, but that will also, 42 is a nice number. I mean, we all like 42. So I'll start with that, and I can calculate it up to show that it's a real difference afterwards. And then I'm not really doing anything other than printing things in these destroy methods. But I do have the after restore method implemented, and this one takes. I print after restore. I take in the same timestamp. So this is doing exactly the same thing as the init method. But this one just prints that elapsed time is and the restore elapsed time rather than the startup elapsed time. And then I just print the Fibonacci number, but I don't calculate it because this is already cached in my class because I set it here when I created it the first time, even though this init method is never called on the second start, because then it's read from a checkpoint and the initialized event will never happen. I have some scripts to help me with this. These are kind of, now we get into a little more dirty details, but this is I can run Helidon or Quarkus with these scripts. This is here, I set the timestamp before the container starts. So just read the timestamp from my OS. Then I call in my some build scripts to create it. I have a Docker file created for the CRaC. I'll give you the links to all this afterwards, so you can read it. But the Docker file will do the build of the system, and it will actually build it on Tamarin. Then I will do a Zulu, because I need Zulu to do the CRaC things. And then I'll set the CRaC files is where I'm gonna read the stuff from, and then I'm gonna do the checkpoint and call this entry point script, which is down here where I set the CRaC engine to warp. I point to the CRaC files directory where it's gonna save the endpoint. And if there aren't any CRaC files there, directory, it will restore. So it will restore from this file. So it will discover whether it's restored or not. So I think it's easier if I just run this and show. So I can build it with just Maven first. To show that it actually does that, and it has two. I have Maven files for one for Helidon and one for Quarkus there. So I'll just give it the yeah, let's do Quarkus or Helidon. What are you using? What do you like to see? Well, let's do Helidon. POM Helidon clean package. So I'll just build the Helidon application. So it's they're built. So let's see. Then I'll run this checkpoint script. So I'll just make sure that CRaC files. Make sure I don't have the CRaC files directory. Good. And then I'll run the CRaC scripts checkpoint runtime Helidon. So this will take a little while, because it you can see here it prints. I'm starting the application. It's started up. Now it's creating the checkpoint. So and this will take a couple of seconds to because it starts up the JVM, have it running, and then starts writing the file. It takes a little while. So now you can see it says the checkpoint was successful. It's stored it down. And now I can start the file from this checkpoint. But before I do that, I'll start it without the checkpoint to see how it normally would start. And then I'll use this, I'll run it in a container as well, so it's similar. But this one will just start it without any CRaC things. So this startup no CRaC is just a regular java-jar. So let's start this one. Scripts, CRaC, startup, no CRaC. So you can see the prints I'm getting here is, you can see it's startup. That was the I'll open the code for, let me see if sorry. The startup listener, where do I have it? There. So this one says the startup elapsed time is 1.4 seconds. It prints the Fibonacci number. That is the 40-second Fibonacci number. And you can see it takes like 1.4 seconds. I can run it a couple of times just to make sure that we're sort of on the same startup as 1.1. So it is around there on 1.8. So somewhere between 1.5 and 2 seconds. So if I now want to start this one from the checkpoint, CRaC restore run time done. Here we go. So now you can see it starts in 0.37 seconds, but it still have to have the Fibonacci number. And now it's the restore. That this startup isn't written because this isn't called, this init method, because the application scope class is already initialized. So now it calls into the after restore, which is part of the CRaC resource. So now it calls this one restore and print the Fibonacci number. So it still has the Fibonacci number because that was created on the first one, and you can see it's like 4 times faster to start up than it was with the just starting it with the JVM startup. So this is how CRaC helps you. I can run it a couple of times. It differs 0.7. So there was 1 second. So it is a little here and there, 0.7. So it is around there, 0.13, 0.96. So like 70% starter, 75% faster than it was with the no CRaC version. I can do the same thing for CRaC. CRaC, their numbers are a little bit different there. Perfect. Okay. There we go. So and then I'll CRaC files. Just get rid of the checkpoints, and then I'll just do the scripts CRaC checkpoint run CRaC. So now it's creating checkpoint again. It takes a little while, but it's about the same time. This doesn't really matter if it's CRaC or Helidon. It's kind of the same thing. This is CRaC doing its work by storing the checkpoint. So this is the cost of doing it, that you have to do this first. But as you see, it doesn't take that long for this small application. If I now start it with, let's do the startup CRaC startup without runtime CRaC. See, now it's a CRaC application starting, and it also has, this one is 0.8. It has the same Fibonacci number, and I didn't show the actual application, but if we want to show it, let me see here, localhost 8080 random. So it does the different words. So the business logic works. So let's go back to IntelliJ again. So if I now start it, started from the checkpoint. No, not checkpoint, restore. Good. No runtime CRaC. There we go. So now it starts in about the same time. Here it varies a little bit, 0.5. You see, average was up in 1.40. So it's comparable to Halidon, 1.1 or 0.1. So it is around there from somewhere between 0.1 to 0.8 seconds. So it is about half the time almost. So and when I've run this is a demo we did at DevNexus when we compared them. This time we were running on another machine. So we were running on an older Mac on an Intel-based Core i9, and you can see the Halidon has the most improvement by using CRaC. CRaC didn't have that improvement, but it's so fast without it, so you don't really gain much by using CRaC for CRaC. So I think before you start CRaC enabling everything in your infrastructure, you need to do this kind of simple benchmark and see, is it actually faster? Is it worth it? Because it adds some complexity. If I look at how it looks on this machine that I did at home before coming here, there are slightly different number. First of all, everything is faster on this one. This is an M1 Max on Apple Silicon, but you can see the Halidon, it halves the time. For CRaC, the improvement isn't that much, but that is already so fast that it's comparable to Halidon, even without CRaC enabled, when Halidon is CRaC enabled. So here again, for Halidon, I would, if 0.7 milliseconds is important for you, then it's absolutely worth it. If it isn't, then if 1.4 seconds is okay, then it's not worth it. So it depends on the use case and what you have and what infrastructure you're running on, what CPU do you have, how much memory, how does it work, what does your application do. So to sum up, Jakarta 11 is coming next month. We are already in the way of planning for 12. And the way it looks right now is that 12 would have a massive amount of specifications updated. There are only a couple that aren't updated, and most of them will receive updates. There's also a new specification there called Jakarta Query, which is a cleanup or refactoring specification within the platform, since both Jakarta Data and Jakarta Persistence do have query languages. We're moving the common things in the Jakarta Query specification. Good question. They are candidates. Both MVC and NoSQL are candidates, and we hope, at least I hope NoSQL will be a part of the platform. But we haven't done that vote on the platform yet. But they are in the system. They are there with the NoSQL 1.1 and MVC 3.1. Plans are approved. They're there, and we hope that at least one of them, maybe both of them, will make it to the platform. That would be a good addition to Jakarta EE, I think. And this is all subject to change. So if it turns out that some of these specifications aren't making the deadlines, they won't be updated for this release. So follow our mailing lists and our web pages to see what's happening with Jakarta EE 12. So I think this simple demo, and with the help you get from the CDI events, especially the scopes and that CDI scopes events, I think Jakarta EE and CRaC is a good fit. It has all the tools available for you to actually CRaC enable your application. There is some work on your side to actually do it. Some of it may or may not be handled by the application server, but the more we look at it and the more we test out, we can give some recommendations here and there on what kind of applications. If does a database connection come up automatically? Does it fix that, or do you have to actually handle those yourself? I haven't really tried that myself, but that's kind of the next thing I'm going to test, is just to see if I have a database connection, is it there when I restore it? That would be a great help, and then it would be much better. While working on this, we also have an idea, maybe we should think about the Jakarta CRaC specification. It will be more maybe adopt the CRaC APIs. If they were willing to donate it to Jakarta, we can have those APIs. Maybe we should add some CDI annotations on top of that, so you can annotate your application where you need to kind of signal to the container that some resources needs to be handled here and there, to make it clearer to use, like the at before checkpoints annotation, for example, or something like that. It's an idea I'm playing with. I haven't really got people to invest in the idea yet, but the more I repeat it, then maybe it can happen. We'll see. There is also another project called Project Leiden that is very interesting. And this is a project that there may be use cases where CRaC is better, and there may be use cases where Leiden is better. But Leiden is kind of less intrusive on your application because you don't need to do anything within your application. This one does the optimization on compile time. So that's a big difference there. And depending on how your application is, it may work or it may not work. Project Leiden is also just a project being worked on at OpenJDK. So we don't know when it will or if it will ever make it into the JDK. But it's an interesting project to keep an eye on. And there are builds out there with Leiden, so you can try it out and just do it in a compile of your application and see how the startup is. It looks very promising. So this one could be a option to use rather than CRaC if you want to go that way. With that, these are some resources you can use. You can see the Rustam's GitHub repository. That's where we have the application we looked at, so you can go there and check it out. If you want to just try out Jakarta EE, you can go to start jakarta.ee and generate a project and get running with it. If you want to learn about CRaC, you can go to OpenJDK and read about CRaC there and follow their mailing list and see what's going on. And that was what I had. So I thank you very much for listening. And if you have any questions, feel free to ask them in Slido or just raise your hand. I don't see any questions here, so it could be, yeah, so retry. Let's see. Oh, there's a question. Yeah. So how does it confirm to the Open Liberty instant on? Yes, so IBM has a concept that is exactly the same as CRaC. They just call it instant on. It works on their OpenJ9. So that works the same way. And there are some fabulous demos on the IBM webpage where you can use instant on with Open Liberty, and that's comparable to what we're doing there. They're building it into Open Liberty. So that's, if you're on the IBM projects, that's the tool to use there. It's implement the same APIs. They have some different names on it, but it's the same thing before checkpoint and after restore. All right. Thank you very much for listening, and thank you for staying this long. And Werner, you have a question? Okay, so how does CRaC compare to Instant On, or how do CRaC compare to GraalVM? Okay, so how do CRaC? We have it in the code. You probably saw some Docker files with GraalVM. You can do that. I didn't do that for this talk, But if you go to that GitHub repository and get the random strings application, there are some scripts and Docker files for that where you can try it out. I haven't tried it myself, but GraalVM will definitely be a bit slower on compile time because it does everything there. That will be the optimization of the application. So you still have to, yeah. So you will get all the GraalVM benefits, but running on with GraalVM or native images will probably on the long term not give you the same performance benefits as when the JVM optimizes itself, because the JVM just gets faster and faster. But GraalVM, they reach a level, and that's where it's at. One more question. So the question is whether build-time injections, runtime injections can have something to say. Yes, that could have. When do they initialize things? Do they do it when they get a request to the REST API? Do they then set up the Jakarta REST thing, or do they do it beforehand? So it's different how the implementations are. That could be a good point. Another point is actually, Rustam pointed out to me right before this talk that there is a bug in his script. So when he's fixed that, these numbers will be different a little bit, but the kind of the trends of them will be the same. Thank you very much, and enjoy the last talk of the conference, which is coming up after this one. Thank you very much.